Hi all, welcome back. This is Tech Guru and I'm back with my another tutorial. Today we will learn about how to design a hydraulic cylinder, okay, with the top-down design approach using layout in Creo. Okay, there are many ways of create. There are many ways in which you can use top-down assembly. Okay, people use skeleton model, then they've used layout, different ways of doing top-down assembly design in Creo. But today we will do the top-down assembly design using only layout and assembly model. Okay, of course you have to use assembly model for top-down design. Okay, so what we have to do is to do this top-down design assembly. There are two branches. Okay, two subdivisions. First is you have to create a layout. Okay, layout with all formulas and everything. Once this is done, then you have to create assembly using layout. Okay, so first we will do layout work. Okay, what is layout and all I'll tell you later on. Okay, but there are some prerequisites. What is that? To create a layout you need a drawing. Okay, so I have already created a drawing of hydraulic cylinder. So this is the drawing of hydraulic cylinder. What we need to do is to create a layout. First you need to save this .drw file to .dwg file. Okay, and I have done that too. We have some first thing you have what to do is you have to go as save as, save a copy, and then here you have to pick what you can say dwg file. So I have already created it as hydraulic2.dwg. okay, once this is done, close everything. Once you have saved a dwg file, close it, go to new, then go to notebook. Okay, you give your name as hydraulic2. okay, then click ok. Pick the same size as your drawing, drw drawing. Mine is d. Okay, then I'll say okay. So a layout is created. Now import your dwg. So okay, here it is. Your dwg file is imported down. Now you have to use this as your reference for your various dimensions and create a assembly. Okay, so what we will do now is, first thing first, whenever you design a hydraulic cylinder, you need input. What are different inputs for hydraulic cylinders? They are force, stroke, and working pressure. Okay, so now we'll do it. I'll first write a note over here. Okay, there are few note information that we need to put it on our layout. Okay, and then go here, tutorial, video tutorial, and here I have all the material information. I'll copy from here, paste it here. Okay, so the material that we are going to use for hydraulic cylinder creation is C40. It has a tensile strength of 58 kg per mm square. I'm using a factor of safety of 4 for entire cylinder. So my working stress after using 4 as factor of safety will become 14.5 kg per mm square. And the seal box, only for seal box I'll be using factor of safety as 2. Okay, and then my input of pressure, working pressure will be in bar, which I have to convert it to kg per mm square. Okay, then once this is done, I will save it. Then I will import a table for import table which has information about basic information about force, working pressure. This is in bar, that gets converted to kg per mm square, that is working pressure, working stress, stroke. Okay, then I will import one more table. This table you need to create it in advance, or you can ask this table from me. Okay, then these are the different various parameters of the cylinder. Okay, these values will be calculated using formulas, and these are your input values. Okay, now once I have done this and this, now let's create some parameters. These same parameters will be added. Okay, go here, say parameters. What are the parameters? Force. First is force, FORC force. I want a force of 20 ton, that is 20,000 kg. Okay, then comes working pressure, PRE in bar, which is 255 bar. Okay, then I have working pressure in kg per mm square. Working pressure, PRE pressure, which will be calculated, of course. I'll simply say 1 as of now. It will be calculated. Okay, then comes working stress, which is 14.5. I have calculated it as 14.5 kg per mm square. Then stroke, STROKE, stroke. I want stroke of 500 mm. Okay, once this is done, say OK. Then all that you need to do is pick this, go to tables, select column, and without any hesitation delete it. Okay, then go to column and write as this. Then go to annotation, write it down as value. Okay, and then center it off, and then make it red. Okay, then go click here, with ampersand you write the value. What this does it, when you add ampersand, you'll get all the values from parameters. Working pressure I have typed. Okay, STRE stress. So now we have all the input values typed into our column. Okay, now comes calculated values. Okay, save this. Now you cannot calculate immediately until unless you define the parameters on your, what you can say, drawing. So which is the first parameter? That is cylinder underscore ID. Where is your cylinder underscore ID on the drawing sheet? Here it is. This is your cylinder underscore ID. So click this, type here, write CYL underscore ID. Click this. For time being, simply type 10. Okay, so this way you will have to do for everything. Okay, it is also, every description is given here so that it becomes very easy for you to check where exactly these things go. Okay, I'll just go on giving everything. Okay, cylinder underscore thickness. Added on the layout. Okay, now we have to connect these dimensions, okay, with the input values and get all these values as calculated values here. We don't need to do anything. Everything will be self-calculated. For that, what I have done, I have created a list of formulas. Okay. So in the beginning of this tutorial, you found some slides. In the slides, everything is clearly mentioned. What are the formulas for everything? Okay. So what I'm going to do is I'm going to go here tools. I'm going to go for parameters. So I want to cross check whether I have 17 parameters here. I'll be having an extra parameter WW, which will not be considered. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This will not be considered. Okay. So try to delete it here. It's gone. 11. So here 17. Now go to, once this is done, say OK. Go to relations. Okay. Go here and I have all the formulas. All that I'm going to do is, these are the formulas which I have written. Okay. Just to save the time, I have kept it here. You simply copy and paste it. Check it. All verified. Okay. Now click here. Okay. Now I'm not getting any value here because there are no ampersands. So let's see if I can add ampersand and get the value. So what I need to do is, I have no other option but to click here, go to tables, select column and delete it. Go to column and add one. Okay. Once done, go to annotations, write this as calculated values. Okay. Center and here. Now everything just copy down here with ampersand. See, everything comes calculated. Piston thickness and piston ID are the two things which did not get calculated. Okay, so we will fix it. Go to tools, relations, and then what is it? Piston thickness. It should be TKH. TH, it should be THK. Okay, once that is done, then done. Piston ID. It is this internal ID, piston ID on rod diagram. Okay, so how much is it? The rod dia is 35. Okay, so what you need to do is, once you calculate rod dia, okay, go to the next lower thread level. It can be 30 can be 30 mm, okay, 32 mm, 34 mm. Okay, what I will do is, I will pick as 34 mm, 30 mm as the rod dia. Okay, so I will go to tools, parameters, and add 30. Here I'll add 30. Okay, then 30. Then everything has come up. Nut dia, outer one is okay. Nut thickness, everything is okay. Rod extension. Now rod extension, rod length, this is important. Here I need to make some changes because it is not correct. So, rod length is not correct because rod extension itself is not correct. This is rod extension. I don't need this much value. Okay, so rod extension, what I will do is I'll reduce it by half. So go to relations, rod extension. Rod extension is stroke 500 is stroke divided by 500. So I want rod stroke to be 10. Then calculate 50. Perfect. Now rod length. Okay, rod length is again can to be understood. Relations. So rod length is rod extension stroke. This is all correct. Distance thickness, nut thickness. Correct. Distance thickness. Then here there is nut thickness stroke. And I need to add 3 more values to this. That is seed box outer thickness. Outer THK plus seed box thickness. Seed box THK plus seed box cushion thickness. Seed box CUS THK. Okay. Just say this. It's verified. Now check the value. Okay, 663. Rod length is 663. Okay. So now what we will do is we will center this all and then take a look at it once again. Okay. Nut ID. Nut OD we know, do we know nut ID? We'll add it. So here table add row. Okay. Nut ID. Okay. That's mm. Nut internal IAMETR internal diameter. Okay. So this is it. How much is nut ID? Nut ID is always equal to piston ID. Okay, because the readings will remain same. What I'm going to do is I'm going to put a threading here. Okay, so if this is 30 mm, this is 30 mm, then if this nut has to get fastened to the piston end, piston and this should have same ID, same net values, nut thread value, so it should be same. So I go to relations, tools, relations, then what I'll do is nut dia ID is equal to piston heading. Piston ID. So piston thickness here, piston heading of yes, piston ID. Set. So then write it here as nut underscore heading. What do we get? Perfect. Okay. So guys, now our layout is ready. Okay, so this is the layout value. Perfect. So after converting 255 bar to kg per mm square, it becomes 2.6. Okay, working stress is this. This is this. So I have used seal box factor of safety as 2. So that is the reason why my seal box values will be far different. So this is the value which I got. Now what I'm going to do is these are all the values which I am going to text it as 0.50 because they are not visible. will all jumble up. This down. Okay, this is fine. This you can put it outside. Cylinder list out. Properties. Text value 0.250. 0.550. Okay. Cylinder ID length. This has gone out. We can take it up. Keep it here. Okay. Don't bother about the dimension lines intersecting each other. This is just a tutorial for you people. Okay. Rod dia comes from buckling load, Rankine's formula, and cylinder internal ID comes from equation of thin and thick cylinders. Okay, pressure vessels. Okay, so once this is done, our layout procedure is over. Okay, so what we will do is, now next is we will go to creating the assembly using layout. Now we need a cylinder. Okay, cylinder model. We have to create an assembly from this. For that we have to, what we need to do is, we need to use this layout in the assembly to create the hydraulic cylinder model. That we will start. Okay, I'll pause this cylinder. Okay, that you can find it in the next my second video, part 2.